Hey guys, it's Miss Jensen here, and I'm here to bring you our first video for the next chapter, which is all on probability. Today we're talking about the counting principle and how we use it and why we use it. Well, one example of why we have it is because if we were wanting to make a list of something like the number of possible license plates for a certain state, if you think about the license plate in Minnesota, we have 3 letters and 3 numbers. And if you think about all of the options that we have for all of those, making a list of them, starting with A, 0, 0, 0, that would be a really, really long list. So instead of making a list of all of those, we use something that's called the fundamental counting principle. But before we get started on the fundamental counting principle and how we use it, we need to recognize some terms that we're going to be talking about throughout this unit. So the first term that we need to familiarize ourselves with is the term outcome. An outcome is a result of a single trial. For example, flipping a coin has 2 possible outcomes, heads or tails. Okay, so that's an example for you. Sample space, the sample space is the set of all possible outcomes. So the total possible outcomes when you're rolling a die, like this number cube over here, is having the numbers 1, 2, 3, 4, 5, and 6. So the sample space would consist of those 1, 2, 3, 4, 5, and 6. An event is one or more outcomes of a trial. So rolling a die, flipping a coin, just actually carrying out one of those things is an event. And then we have 2 different types of events. We have independent events and dependent events. So an independent would be the choice of letters and digits on a license plate. For example, picking an A here is independent of picking an A here, which is independent of picking an A here. It's not as if once I pick an A, that has to be gone and I can't use A again. That would make them dependent. But these are independent because one does not affect the other. So as long as one doesn't affect the other, then they're independent. It's when one does affect the other that they become dependent. So for example, choosing a piece of candy from a jar without putting it back and then taking another piece of candy. So you reach into a jar, you've got a bunch of candy, you take one out. Now you've changed the possible outcomes for the next person who takes a piece of candy. That's dependent. One depended on the other, one changed the other. Let's take a look at example 1. It says a sandwich cart offers customers a choice of hamburger, chicken, or fish on either a plain or sesame seed bun. How many different combinations of meat and bun are possible? So we can make a tree diagram of this. This is one way that we can figure that out. If I make a tree diagram, that means I'm looking at the type of meat. I either have hamburger, chicken, or fish. So I would have hamburger, chicken, fish. And I also want to look at the type of bun. So if I pick hamburger, I have a possibility of plain or sesame seed. If I pick chicken, I have a possibility of plain or sesame seed. If I pick fish, I have a possibility of plain or sesame seed. So that would be to make the way of making a tree diagram. Now this tree diagram is pretty small. It doesn't have a whole lot of choices at the end. I have 1, 2, 3, 4, 5, 6 options. So it wasn't too hard to make, but a tree diagram is not always the most reasonable way to make a list of the outcomes. We also have the fundamental counting principle. So if I think about the number of outcomes for each event, if I look at the meat and I look at the meat does not affect the bun. What I pick for meat doesn't affect what I pick for buns, for the type of bread that I use. So that would make this an independent event. They're independent of each other. And I need to look at how many options I have in each category. Well, for the meat category, I have 3. For the buns category, I have 2. And 3 times 2 gives me 6 possible sandwiches. So that's where I got 1, 2, 3, 4, 5, 6 at the end of that tree diagram. And I also get 6 when I use the fundamental counting principle. So the fundamental counting principle just tells me that I can take the 2 categories and I can multiply them together. If you have 4 different categories, you take all 4 of those and multiply them together. And as long as those things are independent and they don't change each other, then that will give you the accurate number of possibilities. Let's take a look at Number 2, it says to check a voicemail, owners may have to enter a 3-digit code. Determine whether choosing each number is an independent or dependent event, and also determine how many possible codes they are. So let's first just ask ourselves, is this going to be independent or dependent? If you have a code that has 3 digits, you have to think about how many digits you have for the first number, for the second number, and for the third number. How many options do you have for each one? And will they affect, does the number that I picked in the first spot affect the second spot? Well, in this case, no, it doesn't. I could pick a code that's 111. I can repeat the ones, I'm allowed to, and that one didn't affect this one didn't affect that one. These are independent events again. So now think of how many options you have for each digit. In each digit, we could enter the numbers 0 through 9. Don't forget to include 0, which means I have 10 possible choices. 10 possible choices for the first digit, 10 possible choices for the second digit, and 10 possible choices for the third digit. I take those and multiply them together. That means I have 1,000 possible codes. If I take a look at number 3, now it says Carly wants to take 6 different classes next year, assuming that each class is offered each period. How many different schedules could she have? So now we want to ask ourselves, does the class she picks for the first hour of the day affect the class she picks for the second? Well, in this case, it actually does. Let's say you picked math to be your first hour of the day. That means math is now no longer one of your choices for the rest of your classes. Then let's say your next class is science. Now, science is no longer one of your choices for the next class. So it does affect the other because you're reducing the number of choices each time you assign a class. So these end up being dependent events. So if I look at calculating the number of different schedules she could have, I have 6 different classes, which means there are 6 spots that she has to fill. 1, 2, 3, 4, 5, 6. So when she puts a class in the first spot, there are 6 classes to choose from. Okay, she has 6 classes to choose from for the first hour. Once she assigns one of those classes, she then has to put a class in the second spot. Well, now there's only 5 choices because she's assigned one. So then there's 5 choices for the second hour. Then once she assigns that one, now there's only 4 choices for the third hour. Then only 3, then only 2, then only 1. That is what we would multiply to get the number of choices. When I multiply that out, I end up with 720 possible schedules. Okay, so this time using the fundamental counting principle, my events were dependent. So I had to consider what that did to the next event and what that did to the next event and what that did to the next event. I'm gonna go ahead and stop our video there. Thanks for watching today, and don't forget to hop back to Schoology and take your quiz, and I will see you all tomorrow.